Hello and welcome to the session. In this session, we'll be discussing about the building blocks of an algorithm. But what is an algorithm first? An algorithm is a well-defined computational procedure consisting of a finite set of instructions to carry out a specific task either by hand or on a machine within definite period of time. Now this is how we define algorithm. Looks very complicated. Rather than looking into this detailed definition, we would like to define it in terms of characteristics, right? So in first characteristics of an algorithm is that it is independent of a programming language. So whenever you are writing an algorithm, you are not worried about which programming language you are going to use, right? Whether you are going to implement that particular algorithm in C, C++, it really does not matter. What are the other characteristics of the algorithm? Well, other characteristics of the algorithm, if we see from the definition, it logically comes out. First one is the input, right? So every algorithm has finite number of inputs. Okay, then once you have certain set of inputs for an algorithm, it has to process that particular input data and come up with some output. Without that, this particular algorithm is going to be literally useless, right? So there has to be an output procedure. Procedures at least one output produces at least one output carrying out the algorithm. Then we have definiteness, has a definite sequence of operation for transforming into input into output. So an algorithm, there has to be a definite sequence of instructions which has to be followed, and we would like to discuss this particular sequence of instruction, right? So this has this sequence of instruction which is to be followed to produce the output. Then the next is the effectiveness, right? So every step in the algorithm is essential. Why? Because if a particular step is not essential, it is going to lead to unnecessary waste of time, whereas we want our algorithms to be very, very efficient, right? Then comes the finiteness, or the most important component or the characteristics of an algorithm, that an algorithm must terminate in finite amount of time, right? Finite number of steps. It should not go on infinitely, right? So this is the last but the most important, that an algorithm has to eventually terminate, right? The task should be completed in finite steps and the algorithm must stop eventually. That's what we call the finiteness. Well, how and why we want to develop an algorithm is basically for problem solving. But let's try to explain the building of an algorithm with the help of an example. And one of the simplest example which we can take here is the computation of greatest common divisor. Now, Euclid developed a very good method for computing greatest common divisor for two numbers. And this particular algorithm is what we are trying to, first of all, let's understand the process of this particular this common divisor. Now, take example that given two integers a and b, our objective is to find the GCD using the Euclid's method. Now, in this particular case, we are going to take an example with the value of a as 1071 and b as 462. Now, what Euclid said, that you can use remainder operator, right? So remainder operator, which is shown here, it is called the mod or modulo operator, where remainder equals to a mod, where you have a mod b. So the remainder, if I divide a by b, whatever would be the remainder, that will come into R in this particular case. For example, if I divide 5 by 2, then the remainder is going to be 1, right? Because 2 2s are 4 and 5 minus 4 becomes 1. So that is what 1 is going to come in R. Now, how this particular algorithm will proceed? In the first iteration, now we got to work up this particular algorithm. Okay, so first iteration is going to be, we will start with the value of a as 1071, which happens to be this value, and b value happens to be 462. So when we divide 1071 with 462, what we get is twice. So it is going twice, and what we get our remainder as 147. Okay, so the resultant remainder, you can compute, all the steps are shown over here. Then in the next step, in this Euclidean's algorithm, what we are going to do, 462, which was B, will be transferred to A, because why we want this particular iteration to happen? The remainder is not 0. As soon as the remainder becomes 0, that is the time you are going to stop this particular algorithm. All right. So now what you are going to do, 462, which was B, is going to be transferred to A, and the remainder which you have computed, which was not 0, will be transferred to B. So now the next iteration or the next step is going to be, if you find, like the problem of finding the GCD of 1071 and 462 now becomes the problem of finding GCD of 462 and 147. In fact, Euclid proved that this is how, if you find the GCD, it's going to be correct, still the correct GCD. So that is how they have already proved this particular algorithm. So then you perform this particular operation, and what you get as remainder is, in this particular case, your quotient is going to be 3. So you perform that particular operation, and remainder is going to be just 21. Still remainder is not 0, right? Still it is not 0. So therefore you are going to perform the third iteration. However, for the third iteration, once again, B will be transferred to A, and the remainder is going to be transferred to B. So once you have done this particular stuff and you perform what you find, the remainder is 0. So the last value of your B happens to be the GCD, which happens to be 21. Now I want to convert. So this is a typical process of computing the GCD, right? Now I want to convert this GCD process, okay, into finding the value or finding an algorithm, Euclid's algorithm for finding GCD. So how I am going to do that? Well, in order to do that, I am going to start with this particular algorithm. So what is the input to this particular algorithm? If you remember, the inputs are A and B only. So we begin like GCD Euclid algorithm. And to begin this particular algorithm, this is where pseudocode of the algorithm, closer to any programming language, but not in any programming language in that particular way. So input 2 natural numbers A and B. That's what you want to input. Then the next step is, you are performing several iterations here, right? Why you are performing those iterations? Because the remainder is not 0. Okay, or in fact, the value B which is being transferred, right? The value of this 21 remainder was transferred to B, right? So what you are checking in this particular case, actually remainder is getting transferred to B in the process, inside the loop. So that is why we are checking while B is not equals to 0, do, okay? So this is how you are going to start. So while B is not equals to 0, what you compute the value of remainder with the help of A mod B function, right? Operator A mod B. Okay, once you get that particular value, suppose, and then as a next step, you transfer the value of B to A. That is what you have done here, right? In the next iteration, the value of B was transferred to A. This is exactly which has been done here. Okay, and the value of remainder is transferred to B, right? So this is what you have already done. So remainder has been transferred to B, and thereafter you loop, right? So basically you go back and you loop at this particular point. So it checks whether B equals to 0 or not. If it is not, it goes through. If it is 0, then what is output? The value of A is output. Why? Because A has already got the the last value of B. In this particular case, you can say the next iteration will contain A as 21, right? When this terminating, B will be transferred to A. So it is A is going to be 21 and remainder 0 will come to B. So at that point of time, your A contains the output or your GCD. So that is being output. So you have to be very careful what exactly or how exactly you convert a particular way of solving problem into an algorithm, right? So what are the main building blocks of this particular algorithm? Let us discuss in more details. So let's look into the basic building blocks of an algorithm. First, it is the sequencing, okay? The second, selection or decision making. Third one is iteration or looping. That's what we discussed right now. Fourth one, which is not discussed in this particular example, but we will be discussing about, is procedure and recursion. Thereafter, we will be discussing about recursion. So in general, most of the simple algorithm just use the first three, that is sequencing, selection and iteration. First three building blocks. Let's try to discuss each one of these building blocks with the help of example, as well as first try to understand what that particular building block is going to be. Right. So sequencing is a problem can be solved by performing some action in a sequence. That's what you want, right? The order of execution of those actions is important to ensure the correctness of an algorithm. This I would like to show you with the help of an example. Now, if the order of steps of the algorithm changes and does not follow the steps as specified, it will not produce the correct output as expected in the given situation. Let's take the example once again, the Euclid's algorithm. The sequence of action which we had was R gets the value of A mod B, A gets B, and R is transferred to B. So how this particular sequence is going to be? Suppose we have the value of A as 146 and the value of B is 20 for this particular example. So when you perform this particular computation on R, what you get? 27s are becomes 140 and 6 is the remainder. So you get a remainder of 6 in this particular case. All right. The next step in this particular case is A gets the value of B. So A, which was 146, now gets the value of B. So A becomes 20 and the value of B becomes 20. Okay, it remains 20, R remains 6. Okay, and then as a final step over here, the value of R is transferred to B. So what we get is that the value of A becomes 20 and the value of B becomes 6 in this particular case. All right. Now, if instead of this particular sequence, this is what we wanted, right? So new values, once again for finding the GCD, A as well as B, 20 and 6. Now we can once again start with the value of A and B as 6. So 6 3s are 18 because B is not 0. So we will divide it and get 2 and so on and so forth. So we can go on using these particular steps. Okay. But the important thing is the sequencing of this particular step. So this is a typical sequence. Suppose you change the sequence. So R in this particular case is not applicable. Right now we do not know. Okay. A is the value of A is 20 and let's say B is also 20 in this particular case. So let's say A is 20 and B is 20. Now when you do this particular operation, what is going to this particular operation is going to result? So A was 20, B was something else. Let's say B was 6, but B is also, or let's say in this particular case, B was 20. So the value of B is transferred to A because of this particular operation. So it's no longer is 146 and A and B both values become 20. Okay. So the problem here is when you find out A mod B, you get R equals to 0. and you do not know whether it is the correct GCD or not correct GCD. Why? Because the sequencing is a problem in this particular case. Now, in the third case, you see, we still start with the same first step, but just interchange these two steps. That is, the value of B is assigned R first, and then later on, the value of A is assigned B. Now, in this particular case, what you get? The value of R was 6, right? It was computed in this particular step. Value of A was 146. So the value of R was assigned to B, which was 20. So it becomes 6. And when you change B to A, when you assign value of B to A, you get all values as 6. Once again, that is in error. So the correct sequence is very, very important. You can see this effect of current sequence, that we are leading towards the GCD, computation of GCD. If you do not follow the correct sequence, you are bound to end up in some sort of problem. So this is the example of sequencing. So it is very, very important that you choose proper sequencing in an algorithm. Moving on, the next step is the selection. Now, in some cases, the sequence of execution of instruction may depend on some condition. It is like the same action to be performed is dependent upon some Boolean operation. So suppose we have a particular condition over here. If the value of B equals 0, right? Equals means it is being compared. The value of B is compared to 0. If it is 0, then it simply returns 0. Okay? The value of B is 0, so it simply says yes, or the value is 0, let's say that way. Okay, else you return the value of R, A mod B, right? So this is so in case B is 0, it simply returns 0. Otherwise, if B is not 0, then it will compute the value of A mod B, and that is the if condition. So this is the selection, and most of the time selection is one of the most important statement when you are writing your own programs or building your own algorithms. So it is very essential that you come up with or use selections wherever possible. Now, the next step, which we have done already, but we would like to repeat in some sense, is iteration. Now, iteration is while solving problems, certain instruction may be executed a certain number of times or until a certain condition is met. So this was the one which we did, right? While B is not equals to 0, do, right? So this particular things are to be will be repeated. Okay, so for example, it was repeated for A equals to 1071 and B was 462, A was 462 and B was 147, A was 147 and B was 21, and thereafter one more times when this particular loop terminates, when we assign the value of A as 21 and B as 0, right? So this loop, while loop, right, this is iteration. It is being repeated 3 times. The sequence of step is being repeated 3 times for different values of A and B, and that is how you are leading towards, you are moving towards the end results. And that is the beauty of iteration, right? So the 3 main concept is, as I told you, that if you are working with an algorithm, the sequencing is very, very important, selection is very, very important, and the third one, iteration, you may be using many a times. If it is slightly complex algorithm, you are bound to use the iteration. What about functions or procedures? Well, the procedure are the basically terms used. Different terms are used for procedure, either subprogram or function. These are some differences in their usage. In fact, it should be there are some differences in their usage in different programming languages. But the basic idea behind these terms is the same. So they do perform the basic step, a particular thing. That repeats the same sequence repeatedly in one or different algorithms or programs. So this is something which you do repeatedly. Okay, you can write one procedure or function and use it in same or different programs. So you can perform that particular task. a very natural way of solving the problem by reducing complexity. So making procedures is one of the way of solving or reducing the complexity of your algorithms, or reducing problem of your programs by creating small subprograms and reusing those subprograms or procedures. For example, the GCD algorithm can be written as a procedure. So how we can write the GCD algorithm as a procedure? Well, the GCD we are writing as a function, right? So function or procedure are somewhat similar, but there may be slight difference depending on the programming language. Let's not discuss about the differences right now. Let's understand the logic behind what we have done. And this function is in C programming language. So function is an implementation, right? So the GCD Euclidean. Now notice the difference here. The first thing we are using in the function are the parameters, and there is a return value, right? So this particular GCD Euclid is going to, the input is A and B, which basically will be passed to this particular function as parameters, and the output is going to be the name, only one output, which will be the GCD value, computed GCD value by this particular function, right? Next has the same sequence as you have the other, except we have added one more statement here, which basically is a if statement, which is a selection statement. So this particular statement will be executed if A and B, by any chance A or B, either A or B, any of them is below 0, it will just return 0. While B is not equals to 0. So what do you do? This is the same step which we have written in the program, except we have replaced mod by percentage. What does this percentage mean in this particular case? It's the mod function in C programming language, right? Mod operator, right? So this is how we have done. And when we said B goes to A, so that is equals. This is called assignment operator in C. Right. So B is, the R is assigned to B, B is assigned to A in a particular sequence, right? And that sequence cannot be changed. If you change the sequence, we know what problems you can encounter. Now, this particular thing will become function. Now, in order to call this particular function, right, to find the value of GCD of integer x and y in an integer variable GCD, this function will be called in the main program as. So these x and y, right? So these are called the formal parameters. A and B are called formal parameters, and x and y in the main function or the main program will become your actual parameters. So suppose x is 5, y is 10, then these two values will be passed down to A and B automatically by this function call, which is GCD equals to GCD Euclid x and y. Remember, we said that it is going to return a value. So whatever integer value this particular function is going to return will go into variable GCD. So this is how the functions work in a programming language. And function, as I told you, are one of the most important component in if you want to reduce the complexity, right? So if you are writing bigger programs, definitely you are going to write functions in those particular things. Even in object-oriented program, you are bound to write many functions in that particular way, because as a method, small methods you write. So functions you are bound to write in most of the programming languages, right? Now moving on to the final component, which is recursion. Now recursion, let us try to understand with the help of an example. For example, I want to compute the factorial of a natural number n, which is defined as factorial 1 equals to 1 and factorial n equals to n multiplied by factorial n minus 1. Now this is a recurrence formula or recursive formula for computing the factorial value, right? So now how do I compute value of factorial 4 using this particular recurrence relation or this particular recursive formula? Now I basically recursively call this factorial 4, right? So we will pass 4 to n. So this factorial 4 is actually will be computed as n will be replaced by 4. So this is 4 into factorial n minus 1 is 4 minus 1, which is 3, right? So we'll be calling factorial 4 equals to, will become 4 into factorial 3. In terms, factorial 3 will be calling another function 3 into factorial 2. Factorial 2 will be calling 2 into factorial 1, and factorial 1 is 1, right? Now these values would be substituted here, right? So factorial 1 is 1, so it is going to be substituted here. Now factorial 2 will become 2 into 1, right? So factorial 2 will be just factorial 2 is 2 into the value of factorial 1 is 1. Next, factorial 3. So here is factorial 3. Factorial 3 is basically computation of 2 into 1. Like that, the final value, like that you will be coming up with the final value as 24. So now the factorial procedure is basically, this is the simplest factorial procedure which computes, which equates the value of whether n is equals to 1 or not, and it returns 1, else it returns this particular value, which is how we have shown. The definition of function, so this is recursive definition. Procedure which can call itself is said to be recursive procedure. For successful implementation, there are certain rules which are basically that it should there should be stack based implementation and all those things which are already given in your block. So you must read through that particular component, and with this we come to the basic summary of this particular session. The characteristic of algorithms are input, output, definiteness, effectiveness, and finiteness. An example algorithm we discussed was Euclid GCD algorithm. And finally, we also discussed about the basic building blocks of an algorithm, which are sequencing, selection, decision making, iteration, looping or repetition, and procedure and recursion. With this, we end this particular session. Thank you for being with us.
Are you a fresh graduate? Do you want to fulfill your educational aspiration by pursuing higher education in various interdisciplinary and multidisciplinary